Hello and welcome to LA Geospatial, and this is still raster analysis. So we're going to look at how to create curvature, and this time around we're going to be using the tool surface parameters. Okay, so to do that you go to analysis and then you go to tools and you go to geoprocessing tool and you just search for surface parameters. If you're conversant with this channel, we've used surface parameter so many times. Okay, so we're still going to use that in this video. So you use this, click here, and then you will impute the raster we'll be using, which is this. And here under the input marks, you still bring in this. Now here we have parameter type. Now here is where it gets a bit tricky. We have the mean curvature, we have the profile normal line curvature, we have the tangential normal contour curvature, we have the plan projected contour curvature, and then we have the Gaussian curvature, and then we have the Casorati curvature. Now, if you want to understand all of this, you either read it up or you just come here under this eye that you see here, then you will be able to see all that is to it. The slope is the rate of change in elevation will be computed. This is the default aspect. The down slope direction of the maximum rate of change for each cell will be computed. Mean curvature, the overall curvature of the surface, will be measured. It is computed as the average of the minimum and maximum curvature. This curvature describes the intrinsic convexity or concavity of the surface, independent of direction or gravity influence. Tangential normal contour curvature. This geometric normal curvature perpendicular to the slope line, tangent to the contour line, will be measured. This curvature is typically applied to characterize the convergence or divergence of flows across the surface. Profile. The geometric normal curvature along the slope line will be measured. This curvature is typically applied to characterize the acceleration and deceleration of flow down surface. Plan. The curvature along contour line will be measured. Contour geodesic torsion. The rate of change in slope angle along contour lines will be measured. Gaussian curvature. The overall curvature of the surface will be measured. It is computed as a product of the minimum and maximum curvature. Then the Casorati curvature, the general curvature of the surface will be measured. It can be 0. So with this explanation, you will now be able to know which one to choose and which one not to choose. So for this exercise, I'm going to choose the contour geodesic torsion. Okay, now anyone you choose will go. So once you have that choice, you leave it at quadratic and you hit the run button. So once it is computed, we should be able to see this calculator. So you can see, if you look at this with the previous one, that's the one we calculated just the normal. There are distinctive difference, but depending on the task at hand, I'm just giving you an educational video for you to know all of that. My job is to just give you the educational video. Your job is to learn and apply it to your job. All right. So thank you for staying tuned and watching this video. Thank you for tuning in, and I will see you in the next video.